So now we're going to move on to another chapter. Okay, here, excuse me, here, I think it's chapter 5 in the new book, but basically here we're going to look at trigonometry. First we're going to see what an angle is, just an introduction to that. We're going to see a new unit of measurement for angles called radians. I know there's also degrees, and we'll use that as well. Radians turn out to be a lot nicer to work with mathematically than degrees. Okay, and we're going to look at right triangle trigonometry only. There is general trigonometry where you could define the trig functions of angles that are beyond 90 degrees and negative angles as well. That they do in Math 105, so I'm not going to do that here for time consideration. With radians also, the formal definition is in the book. I'm not going to do the formal definition. I'm basically going to just present how to convert between degrees and radians. I mean, the formal definition is not terrible. I'm just trying to I'm trying to teach as efficiently as possible, so to say. All right. So here, first, for angles, we have to know what a ray is. That's the first thing we have to do. So by definition, really, a ray is just part of a line. Maybe I shouldn't say half of a line, because technically a line doesn't have finite measurement. But I guess in a sense you could say half a line. The idea is if you have a line which extends indefinitely to the left and right, you take any point on that line and you take all the points on one side of the line, on one side of that point, and the other side you're basically going to throw away. Okay, let me just explain that. Here we have a point. So the idea is from a line you take any point you want. You're going to keep everything on one side of the line, on one side of the point on the line. The other side you're going to throw out, like so. That point that you get, so a ray, you'll actually get a ray which looks something like this. This point here is what we call an end point. That's what that is by definition, an end point. Okay? Now, how do you actually form an angle? You rotate this ray about that endpoint. That's just what you do. You rotate the ray about that endpoint. What's going to happen is the ray's starting position, which is called the angle's initial side, after you rotate, it's going to look something like this. Where the ray ends up is the terminal side. And that endpoint is called the vertex of the angle. And basically, as you can see, the green arrow is trying to indicate you're rotating this direction, counterclockwise. Okay? That's what you're doing. Here's the initial side, the starting position. After you rotate the ray is going to be at the terminal side. So basically, you'll end up with something like this. The green arrow indicates what direction you rotate. Theta here, this angle, theta. Well, excuse me, theta, this Greek letter, theta, I think it's spelled T-H-E-T-A. This is what we use to denote the angle. Okay? The vertex here, that's the end point, okay? That becomes the vertex of the angle. So essentially, an angle is formed by rotating, and it's a way of measuring rotation. All right. Now, to measure angles, there are two units here. We have degrees and we have radians. Okay? Degrees are what we're used to. We see that a lot. Radians is something new that, well, though you might have seen it before, but if you haven't, that's okay. Radians is something we're going to see shortly. For degrees, here's the way to think of it. I don't think this is the formal definition, but here's the way to think of it. If you imagine rotating a ray, forming an angle, right? Imagine rotating completely, okay? A complete rotation counterclockwise about the vertex, okay? So that the terminal side and the initial side coincide with each other. You know, so it's almost like you're doing what we did over here. You're rotating, but you're doing a complete rotation, as indicated by this green arrow. You're doing a complete rotation. The initial and terminal side, they're on top of each other. Okay? By definition, that's 360 degrees. So 1 degree technically would be 1 over 360 of this. Now, is that really a good definition? I don't know, honestly, if it's the formal definition, but for now, it really doesn't matter. Notice also we rotated counterclockwise. Counterclockwise, okay? An angle is positive if you do that. If you rotate clockwise, I mean, theoretically you could, but then the angle is said to be negative. So negative 360 degrees would be rotating, doing a complete rotation, but rotating clockwise, okay? Okay. Now, here's the notation for degrees. 1 degree is this, as you can see, okay? It looks like you're raising, it looks like this is an exponent, I know. You're raising this to something, but it's really not an exponent, it's notation. So 360 degrees would be this. So that's what we get here. All right, that's good. You know, so this is 1 degree, this is 360 degrees. I mean, I'm not going to ask you what the formal definition of a degree is on an exam. You know, I'm not going to do that. So, all right. And here's just some other examples. 90 degrees, that's when you do 1/4 of a full rotation counterclockwise. Okay? You do 1/4 of a full rotation counterclockwise. So you're doing this. And again, you're going counterclockwise. That's why the angle is positive. 180 degrees, the initial side is going to end up pointing in the opposite way of the terminal side points the opposite way of the initial side. It's half of a full rotation counterclockwise. That's what 180 degrees is by definition. Okay. I mean, you're not really going to have to rotate an angle this much in this class. But again, if you do go into Math 105, which is pre-calculus, they go more into this because you have to do stuff like this when you're dealing with trig functions of more general angles. But this is what we have so far here. There's also 270 degrees, which is 3/4 of a full rotation counterclockwise, but I didn't draw that. But that's okay. Now we'll get into radians. All right. Now, again, the formal definition of what a radian is, I didn't write it out, mostly because for now it's really not that important. But what is important is knowing how to convert between degrees and radians. It actually turns out that 180 degrees turns out to be the same as pi radians. That turns out to happen. 180 degrees turns out to be pi radians. 1 degree, okay? So from here you get 1 degree is pi over 180 degrees. Excuse me, pi over 180 degrees radians. Pi radians over 180 degrees. That's better. Okay. And theta degrees then turns out to be theta times pi over 180 degrees. Okay. So that's what we end up getting here. And in a similar way, you can actually get 1 radian and theta radians. Namely, 1 radian turns out to be this, 180 over pi degrees, and theta radians is theta times that. So, all right. okay, now really what's more important though is the conversion. To go from degrees to radians, it really follows from this. You have to multiply by pi over 180 degrees. Pi over 180 degrees. That's how you go from degrees to radians. You have to multiply by this. And to go the other way from radians to degrees, you have to multiply by 180 degrees over pi. Okay? That's what you do also. So if you're in radians and you want to end up in degrees, you have to multiply by this. All right, that's good. Okay. Okay, so we have that. That's how you actually convert between degrees and radians, okay? And also, you don't write out pi as a decimal. I know it's tempting to do that. But again, we just don't do that, though. Okay? All right. Also, I mean, I know it's kind of, I wrote out the word radians here. Really, people don't do that either. I mean, if you happen to write it out on an exam, I'm not going to take points off or anything like that. People don't usually write that out, the word radians. So if you have an angle and you don't see the degree symbol, it's understood to be in radians. Radians are nicer mathematically, it turns out. Okay. Let's do some examples of this. So if we have 90 degrees, for instance, okay, what we want to do, okay, is we want to write that in radians. Okay, how do we do that? Well, going by this, we have to multiply by pi divided by 180 degrees. We're going from degrees to radians. So 90 degrees equals this product, okay? And so from here, okay, what we want to do is, well, so, sorry, from here, the degrees cancel, and we get 90 times pi over 180, which is pi over 2. Okay, you know, that's just pi over 2, so, okay. So that's 90 degrees, and radians is pi over 2. Again, I don't write out radians. I mean, if you happen to do that on an exam or something, I'm not going to take points off. I won't do that.